Question 14. There are 52 cards in a pack. 12 cards are picture cards and 40 cards have numbers on them. Melania takes at random a single card from the pack. She keeps the card, which means we do not replace, so not replacing. And then takes at random a second card from the remainder of the pack. Complete the probability tree diagram. So when we first start, we have 52 cards in the deck, so both of these fractions are going to be at 52. Our picture cards, there are 12 out of 52, and there were 40 number cards out of 52, so that gives us the first probabilities. Going down the first route, if a picture card has been removed, that means there will be one less than the 12 that we had to begin with, giving us an 11, and we have one less card in the deck as well, so instead of it being out of 52, it's going to be out of 51. We can use this to immediately figure out what the other fraction is going to be here. Of course, there are still 40 numbers, so there will be 40, and except this time it's going to be out of 51 because we have removed one card from before. For the other one, if we remove one of the number cards, that 40 then turns into a 39. Again, we'll have one less card in total, so it's going to be out of 51. And then the opposite fraction here will also be out of 51. There will still be the 12 picture cards remaining from the beginning, giving us a 12 out of 51, like so. And that is the complete probability tree diagram. What I recommend before even looking at part B, which you can add to this in part A, which can be a bonus, is to list the possible outcomes in some way at the end, just so you have an idea about what these endings represent. So using P for picture and N for number, I'm just going to highlight the fact that we have a picture and picture if we end up at the top option there. Pn, a picture then a number then a picture, and a number then a number. What can also be handy, although not necessarily in particular, is you can figure out what the probabilities would be at the end here by multiplying the relevant fractions along the way. So this fraction times this fraction gives us the top one. This fraction times this fraction gives us the second one, so on and so forth. It's not the worst habit in the world to start figuring out these probabilities straight away. By doing so, you're going to pick up marks in the bag straight away for part B. Speaking of part B, work out that the probability that the two cards Melina takes are both picture cards or both number cards. So we have the situation where we're looking for both picture cards or we're looking for both number cards, and we have the option of one or the other, which means we're going to be adding probabilities together because whatever the chances are of two pictures or two numbers, us having the choice of either means that our overall probability will get bigger. So PP and NN, based on what we have before, that's going to be these two fractions multiplied together for P and P, and it's going to be these two fractions multiplied together for N and N. So I could fill in the probabilities here and here, like I originally said, or I could just write these fractions multiplied together below, which is actually what I'm going to do here. So 12 out of 52 times 11 out of 51, and then we're going to have 40 out of 52 times 39 out of 51, like so. And I can, I don't have to simplify these separately before adding. I can technically just put this into the calculator in one go. And if I do that, I'm going to get 141 out of 221.